Okay, good afternoon, pilot teachers, and good afternoon, students. Good afternoon. Thank you, sit down. Okay, we're going to continue on with our presentation today. Our last lesson, we were able to only do 2 presentations. And from those 2 presentations, I will quickly go through the information with you on the monitor. So if you have missed out on any of the important points that the students have presented, perhaps you could recall and recap from the revision that we will look at. After I complete the revision, then we will continue on with the presentation, and then we will have the third group. And the third group is going to explain to us the feature that they have selected, and that is on formation of gorge. Okay, looking at the feature that, the 2 features that we have already, or the students have already explained. The first one, the formation of a delta. Simple definition given here. A delta is a piece or a flat piece of land formed from sediment deposited by the river or by a river when or where it enters a lake or the sea. Usually, a delta will be formed at the mouth of a river, the end of a river. It is crossed. A delta can actually be crossed by the river, which is often braided, and one of the groups will explain what river braiding is. And note also that the separate channels which are formed along the delta itself are referred to as distributaries. We have a photograph actually showing the Landsat image of the Mississippi River Delta. So here is a bird's eye view of the delta, the Mississippi River Delta, the Mississippi River Delta. Okay, we have another photograph giving us an example of a small-scale delta which is formed in a lake in Austria. So you see, deltas can be of a very large scale, and they can also be a small one depending on the amount of sediment which is actually deposited. The more sediment, the more area built up, the larger the delta. The less sediment, the smaller the built up area, then the smaller the delta is going to be. We looked at some examples. The students were able to show us the formation, but some examples. Here we have an example of the Nile Delta. The Nile River flows, and the mouth of the river is at the Mediterranean Sea. And this is what the delta of the Nile simply would look like. You have a lot of distributaries, and you also have the built-up areas of which have been built as a result of the deposition of materials. Okay, so here we have the Nile Delta flowing, and then out to the area here which has been formed as a delta. We also have an example of the Vada Delta. The difference between this delta and the Nile Delta is that for the Nile and a lot of other deltas also, there are a lot of distributaries that you can see. Whereas for the Vada, and there are also some deltas which are similar to that, you have only a very few distributaries. Here we have an example of a delta, and this is the one for a section again of the Mississippi. The Mississippi River, the delta would look something like this. Deltas are of 3 types, and into grade 12 we are going to look at those 3 different types of deltas that are formed. They can be acute, they can be digitate, or what we call bird's foot, or they can be of what we call eusterine. And those 3 different types of deltas will develop later on in grade 12. But for now, the students have already looked at the stages in the development of the delta, and the stages are already explained from our last lesson. Number 1, stage 1, deposition will usually divide the river mouth into several distributaries. Spits and bars, they arise, and lagoons are also formed. The levees of the river extend into the sea via the distributaries. And again, a levee has already been explained by the group that did their presentation. Stage 2, the lagoons, they begin to fill in with sediments, and they become swampy. The delta begins to assume a more solid appearance. And stage 3, the old part of the delta becomes colonized by plants, and its height is slowly raised as a result of the continuous deposition and also plants colonizing such area. Swamps, they gradually disappear, and then this part of the delta becomes dry land. And again, this section here has been explained well by the group that did the presentation on deltas. They looked at the stages in the development of a delta, the river flowing out to the sea itself, beginning of a lagoon being created. You have the distributaries as shown by the black lines or the drawing, a cross-sectional view of this feature here. Stage 2, you can note now all those sections or areas between the distributaries get to be filled in. The cross-section will show the extension of the land by the deposited sediments. And stage 3, you have a mature delta which is being formed now. And again, the cross-section shows the extension, the further extension. You can see the old part of the delta and the new part as shown, which is extending further out into the sea. Okay, then we had a chance to look at levee, the group that explained what levees are. They are simply the banks of a river that has been raised by deposition of sediment, usually when the river is in flood. They also explained that levees can be natural and they can be man-made. And the man-made levees are usually on river banks whereby flooding takes place easily, and the natural levees are not able to cater for the flood. The stages in the development of a levee or the raised bank. Here you see the level of the water, which is above the deposited sides. During the time when the river is not in flood, sediments start to occur or be deposited at the bed of the river, and at the same time, sediment continuously is deposited on the side to build up the banks, which are the levees. The same river during flood, continuous deposition can take place, and also further deposition on the banks, further raising the bank or the levee. During the time when the river is not in flood, you can see now the accumulation of deposition or deposited materials, and that process continues. In flooding, materials get to be deposited. During times when it is not flooded, you can really see the deposited materials, and the sides which are raised, especially on the bank, can provide what we call natural levees. Okay, finally, sorry, not finally, but today we'll move on then with the other presentations, and perhaps we might have time for 2 groups to do their presentations. And I will now call on the group number 3 to do their presentation on the formation of the feature, a gorge. Okay, over to you now, group 3.
Good morning, class. My group and I are going to be talking about the formation of gorges. Firstly, I'll just define what a gorge is. A gorge is a deep, steep-sided, often rocky section of a river valley. It is often found in the youthful stage of a river valley. Vertical erosion is dominant, therefore it produces a V-shaped gorge. This type of gorge is found mostly in areas of high relief and resistant rocks.
I'll be explaining on how a gorge is formed. Okay, a gorge is formed when one waterfall retreats upstream. An example would be a gorge below the Victoria Falls. And a gorge is formed when a river maintains its course across an area that has been uplifted. An example is the Indus Gorge in Kashmir. On the monitor, we'll have the formation, the stages in how a gorge is formed. The first stage is when vertical erosion takes place, the undercutting of the valley, forming a V-shaped valley. And the second step, the continuous erosion takes place, forming a V-shape into the river flowing, causing vertical erosion. Okay, the third stage, the continuous and forming a deep valley, weathering and mass movement of valley sides, slope wash follows and valley widens, forming a gorge. Okay, we'll have an example. The gorge below the Victoria Falls, like I explained on the chart. And another of this example, the Yellowstone River in River Gorge in Wyoming, USA. Thank you.
A gorge usually occurs in karst scenery as a result of the collapse of caves. The difference between a canyon and a gorge is that canyons occur in dry regions, while gorges occur in wet regions. Okay, like I said, in the collapse of caves, you may be wondering like how this happens. This is due to the acids in rain. Like in a karst scenery, there's like a karst scenery is made up of limestone. So like acids in rain, they fall. Like when rain falls on a karst scenery, the solution occurs, which means limestones are dissolved, and therefore it causes caves to collapse. And when caves collapse, they form a V-shaped valley, which is a gorge. You?
Okay, questions for the group? If we don't have any questions, we are going to move on. Otherwise, if there are questions, we'll get them to be asked quickly.
Excuse me, I forgot to explain on the diagrams here. That we have 3 diagrams here. The first one is the overhead view of a gorge, where we have the hard rock layer. Here's the river, and there's a waterfall here. This place here is referred to as a gorge. This is the side view of this block diagram. And yeah, it actually shows the same thing, but it's like in a cross-section form.
Okay, there's a question here.
Explain why canyons occur in dry areas and gorge in wet areas. Explain why canyons occur in dry areas and a gorge in wet areas.
Okay, like I said, gorge and canyons are the same thing, except that gorge is much smaller than a canyon. The reason why canyons occur in dry regions, it's like in nature. I mean, it's the same thing, except that gorges, they usually occur in wet regions, like areas that have like rainfalls. And canyons occur in arid regions, like dry regions where there's little rainfall. Does that answer your question?
No.
It's just in its nature to form that way.
Any more questions? Okay, if there are no other questions, thank you to this group. Maybe we should put our hands together for the presentation. Well done. Note that listen, for those people who ask the question on the difference between a canyon and a gorge, you will see that the formation of a canyon, for those students who will explain later, is very similar to that on the formation of a gorge. One of the characteristics that you can identify so that you can be able to tell the difference between a gorge and a canyon is that, number one, a gorge is a little bit smaller when you look at generally the landscape and the landform that it occupies in comparison to a canyon. A canyon, the way in which the canyon is formed is exactly the same as that of a gorge, but it is a little bit more larger in terms of the scale. The other difference is that usually a canyon would cross through a semi-arid or a dry area, like in the case of the Grand Canyon. In Papua New Guinea, we have a lot of gorge. The Wagi Gorge is a very good example where the Wagi River flows through. We cannot say that that's the Wagi Canyon, simply because, as explained, in most cases, you would want to see a gorge, or gorges would usually be common in areas where there is a lot of rainfall, a high rainfall region, whereas canyons tend to cross over semi-arid or desert regions. Okay, does that help with the explanation, Christopher? Okay, good. We'll move on. Thank you for your presentation on the gorge, and this time we have Gibest, your group, for your presentation.
Today we're going to be talking about the plunge pool. But before I go on, a plunge pool is not a feature of the last stage, which is the old valley, but it is of the first stage, which is the young valley. Okay. A plunge pool is a depression at the base of the waterfall, as you can see. A plunge pool is a characteristic of a waterfall. It is a basin spread out of the river, channeled beneath the falling water.
A plunge pool is formed due to the hydraulic action which the water falls down. This is the hydraulic action that is formed by the waterfall. In other words, the weight of the waterfall falls with pressure, falling water carves out the depression, carves out this depression here, which forms a plunge pool. In some cases, the depth of the plunge pool may nearly equal to the height of the waterfall. So it clearly says that the height of the waterfall will affect the depression of the plunge pool. Thank you.
By erosion and weathering the river itself, the waterfall retreats upstream. This is due to the erosion from the river itself and the river load. And so in some cases, there can be a plunge pool here, and when the waterfall retreats upstream, the plunge pool then occurs here, also retreats upstream. Because erosion undercuts this soft rock, so the waterfall retreats upstream. Any questions?
Okay, we'll have Christopher first and then we go to Val.
What do you mean when you say that the waterfall retreats downstream? Sorry, upstream.
When I mean upstream, it doesn't it erodes, doesn't actually move, but it erodes this place here, so the waterfall is upstream now. Moves from one place. Does it?
Okay, he's satisfied with that answer. Val, your question?
As the waterfall's eroding the lower part of the, as the erosion takes place, what happens to the hard rock above the eroded rock below it? Does it actually fall, or does that change? Does it change it in the shape?
You mean change shape? Or no. It erodes and everything, but no, the hard rock erodes gradually because the soft rock undercuts it, and so there's nothing holding it, so it's weak, and so it falls down in there.
Does that answer your question, Val? Okay. Okay, if there are no other questions, your chat. Oh, sorry, Francis has a question up front here before we move on to the next group.
Is it in all cases that the hard rock is found on the surface? On the waterfall, yeah.
As you all know, waterfalls are formed by hard rocks horizontal or dipping upstream, so it can be either two. It can be either one of them, but it doesn't have to be horizontal. Some waterfalls, the hard rock dips upstream.
Did that answer your question, Francis? Okay, thank you. Okay, again, thank you to that group for the presentation of the plunge pool. Well done again. I hope your questions have been answered also by those students who did the presentation. Dorothy, your group next. Quickly. Go and move your chart a little bit that way so you can explain by standing on this side. You're going to block.
My group and I will be talking about the formation of a canyon. I just give a brief introduction on canyon. A canyon is a deep, steep-sided valley that forms in those parts of the world where there are long dry seasons. Glaciers have also shaped canyons in mountainous regions. Such canyons usually have a U shape, whereas stream-cut canyons typically have a V shape. Canyons may also form as a result of faulting. Faulting has created many of the large canyons on the ocean floor, but most canyons have been formed by rivers or streams. Rivers may keep running, supplied from distant mountains or even from water that slowly seeps through thick rocks, but on the surface all is barren and dry. Rain falls on the canyon lands in short torrential bursts, and there is so little soil to soak up all this water. It soon rushes and tumbles over the surface, carrying any loose rocks with it. Canyon rivers can be dry 1 minute and raging torrents the next. Rain and rock make a formidable mixture with immense power to wear away or erode the land. These floods are so powerful that large objects such as trucks and even houses have been carried away and smashed. The world's biggest canyon, the Grand Canyon, is a canyon that most everybody knows. One of my group members will further talk on that. But canyon lands are some of the world's most exciting landshapes, and you are sure to want to visit them. But never go down into a canyon without taking an adequate water supply, wearing the correct footwear, and accompanied by an adult. Canyons can be dangerous places for the unwary, and deaths have occurred because people have hiked canyons unprepared.
Okay, I'm going to be explaining the formation of a canyon. A canyon occurs when a river flows across a plateau which is composed of horizontal and alternate layers of hard rock and soft rock. Like this, for millions of years, the river quietly flowing over a gentle plain. The valley it cuts will be deep and narrow. If the region is arid, then there will be little weathering on the valley sides, and the gorge will be very impressive. As this shows, a canyon is similar to a gorge, the formation of a gorge, but the canyon can be formed from the uplifted land through tectonic plate movements. Canyons usually occur in dry regions where large rivers are actively eroding vertically and where weathering of the valley sides is minimum. This means that the valley sides are deepened, then they are widened, as you can see here. When the erosion takes place, it doesn't widen the valley sides, but it just cuts deep down. Canyons of great size develop when the land over which they flow is being uplifted, but at a rate which enables rivers to maintain their course across the area of uplifted land. So if the land is uplifted and the river determines to maintain its course, then it begins to cut deep down to keep the pace with the race of the land. In so doing, the river cuts a series of spectacular gorges, and the deepest and most famous of which is the Grand Canyon. My friend will explain more.
I'm going to explain one, the formation of the Grand Canyon. The Colorado River has cut a gorge 1.6 kilometers deep and 480 kilometers long into the Colorado Plateau. Because of its size, it is called a canyon. The spectacular Grand Canyon carved by the river Colorado is over 450 kilometers long. The steep canyon walls stretching down over 2,000 meters are made up of different rock layers. These rocks are sedimentary rocks deposited at the bottom of the sea millions of years ago. Now, the Grand Canyon is over 2,000 meters above sea level, brought there by more recent tectonic uplift. The rocks at the top of the canyon are the youngest, just 200 million years old, and contain fossils of animals and plants that lived in the waters when the sediments were deposited. Thank you.
Okay, there's a question in front.
Where in the river valley would you find a canyon? On the first stage, second, or the third stage of?
A canyon is usually found in the first and second stage of a river.
Any other questions? Okay, if there are no other questions, we'll put our hands together for this group. Again, thank you very much for a very good presentation. I think they've highlighted some of the ways in which a canyon can be formed, and not only that, they've looked at a case study, and the case study was based on the Grand Canyon. We have time for that. That presentation was the last presentation because we've run out of time, and we are going to look at the other 4 presentations in our next lesson. That will also bring us to the end of our lesson. So class, if you'd like to stand up now. Okay, to the pilot teachers, our keyword for lesson 78, lesson 78 is Ba. Good afternoon, and thank you, students.